So we're going to continue to look at ways we can analyze data, and one way we're going to do that today is by looking at a different type of graph called a scatter plot. All right, so when data has two variables, it has a special name. It's called bivariate data, and you can kind of see like bicycle has two wheels, bivariate has two variables, and when that happens, it can be plotted on a coordinate plane. And that type of graph is called a scatter plot. So scatter plots are going to look pretty familiar to you because they're going to look like a coordinate plane, all right, which we've done before. All right, so the first thing you're going to do is construct a scatter plot of the number of viewers who watch the new seasons of a certain television show. Okay, so we've got a table. We're just going to use this table to put points on our, our graph. And then these dots will make up the scatter plot. Works the same way as a coordinate plane. So season here is going to be our x value. The viewers here is going to be our y value. So I've got an x-axis and a y-axis here too. Okay. One thing I do want to point out to you is if you look at the graph, this graph right here is going 1, 2, 3, 4, 5. Okay, so it's going in order. But here it goes from 0 to 20. So it skipped a whole bunch of numbers before it started going up by 4. When that happens, they use this little symbol down here to show that they skipped values. Sometimes graphs do things like that on purpose, and they can be misleading. So they are not intentionally trying to make this graph look misleading. They're just trying to save some space here. So they put this little symbol here to just kind of indicate that they know, they're aware that they skipped some values. Okay? All right, so we're going to start with season 1. In season 1, there were 31.7 million viewers. So if I go from 1 to 31.7, and you can kind of see these dots were already there for you, but I just wanted you to see how to plot them. So season 2 was 26.3. So again, you're kind of estimating where these are going to be. 3 and 25 would be above 24. 4 and 24.7, pretty close to 25. 5 and 22.6. And then 6 and 21.1. Okay? All right, so you just have some plots or some dots on a graph, and that's called a scatter plot. And when you observe a scatter plot, there are different things you can take away from that. So it says, what can you observe from the data pictured on the graph? All right, so if we look at as the seasons went on in this television show, did it become more popular or less popular? Well, the first season, it had a whole bunch of viewers, right? Lots of viewers. But by the 6th season, that had dropped off, right? So we can say as the seasons increased, or maybe in this case, it makes sense to say continued. Okay, the number of viewers, what? It decreased. All right, so that's just one type of observation you can make from a scatter plot. We're going to look at some more. Scatter plots are used to investigate patterns. These patterns are known as associations. And there are several types of associations. Okay, so 3 of them are pictured below. So the first type of association we're going to look at is a variable association. And that's when you're comparing like what's happening with one variable to what's happening with the other variable. So in this scatter plot, we can see that the points started down here by 0, but as x increased, as we went further this way, and we went further this way, the points got higher and higher. So we can say as x increased, or x increases, y increases. Okay, this is known as a positive association. As this one gets bigger, so does this one. Okay, remember slope. All right, okay, if we had to draw a line, which we're going to do later, but if we drew a line kind of through these points, would it have a positive slope? Yes, it would, because it's going up and to the right. Same thing with the scatter plot. All right, this right here is an example of a negative association. So if we drew a line kind of going through our points right here, we drew a line here, we could see that's positive. If we go draw a line through here, we're going to see that that's negative. So what's happening is x got bigger. What happened to y? Y got smaller, kind of like what we saw in our first example. So as x increases, y is decreasing or decreases. Okay, and so that would be a negative association. And then our third example, these points are just kind of all over the place. So in that case, we have no association. We can't really say anything about what data we've collected. It's kind of all over the place. So when that happens, there's just no obvious pattern. Okay, remember we're looking at scatterplots to determine patterns. This one doesn't really tell us anything. Okay, another type of association is a linear association. So associations can also be considered linear if the data points lie close to a line. All right, so if you are able to sort of see, like, is there a line that kind of goes through those points? Okay, they're not all on the line, but they're all pretty close to that line. And then this would be known as a linear association. Oh, my dog's barking at something. This one, if I try to draw a line here, okay, it doesn't really catch all the points. This one is doing this funky, like curvy kind of thing. Okay, so that's definitely not a line. So we would say this is a nonlinear association. There might be a pattern, but it's not a line. Okay, not a straight line. All right, so if we look at one more type of association, what we're going to be doing is identifying clusters and outliers. Now, we talked about clusters before. That's when you have a lot of data all in one small space. And then outliers are when you have a piece of data that's kind of out by itself. Okay, it stands out as being much larger or much smaller than the rest of the data. So you can see here, they've already circled this part for you. This is what they would consider a cluster. Okay, so these dots are kind of spread out, but we've got a whole bunch of them right here. So we could consider that a cluster. And then this point right here, do you see how most of, like, we could maybe draw a curve, like this is maybe going up. These are kind of close to each other, but this one is kind of far from everybody else. So this is an outlier. And we're only going to identify outliers when they're really obviously out there, okay? So this is an outlier. And so when you are looking at scatter plots, those are the three types of things you're going to be looking for. You're going to be looking at their variable associations, their linear associations, and then you're going to say, do they have any clusters or are there any outliers? All right, so here's an example. Describe the associations, if any, of the observed data. If an association exists, make a conjecture about the winning time in the 2020 Olympics. So conjecture is kind of like a guess, an educated guess. Like if we see that there's some type of pattern going on here, then could we use that pattern to predict what's going to happen in 2020? All right, so the first thing we're going to look for are variable associations, and that's when you have positive, negative, or none. So remember, that's kind of like the slope of a line. So if you picture a line kind of going through these points, is it going to have a positive slope or a negative slope? Well, you can kind of see it kind of makes a line going through here, right? Sort of a line. But it's definitely going down and to the right. So I would say this has a negative association. As what happened? As X got bigger, what happened to Y? Y got smaller, so that's negative. Would you say that this has a linear association? Okay, it's not a perfect line, but it's not completely off, right? It's not bad, right? So it's pretty close. All right, so I would say that this, yeah, has a linear association. Do you have any clusters of data? I would say not really. Okay, so they're not any like super, super close, or you don't have a bunch right next to each other, so I would say no. And then what about outliers? Okay, you have one way up high or way down low. And I would say no, there are no outliers either. Okay, so the conjecture is what's going to happen in 2020. So I have 2016 here. Okay, so 2020 is going to be like over here. Like if I kept going. So if I see the pattern that these points are taking, then where would I predict 2020 would be? Okay, so and this is just a guess. I'm just guessing right here. So I would say it could be between, like here, it was at probably what, 47? Maybe in 2012, I guess. Yeah, 2012. So I would say maybe in 2020, it's going to be a little lower than the 46. So maybe like 45 seconds or something like that. Again, as long as you can make kind of a case for your conjecture, then there's not going to be a right or wrong answer because it's a prediction. okay? It's not based yet on specific information, okay? All right, number 2, the table shows the number of units produced in a certain number of hours at a manufacturing plant. Construct a scatter plot, describe any associations, and then make a conjecture about the number of units produced in 50 hours. All right, so our first step is to actually make the scatter plot on here. So this is going to be, time is going to be down here. So this is our time, and it's in hours, and then this is here going to be our units produced. All right, so when I have 8 hours, so that's between 5 and 10, I make 20 units. So that's like right there. And then 19 and 41, so close to 20, a little more than 40. 16 and 28, 16 and 28, it's not quite all the way to 30. 40, 60, so 40 and then up to 60. 34. And 49, it's not quite all the way to 50. 8 and 28, so 8 again, but this time 28. It's a little higher. 40, 63 would be over to 40, up to 63, so again, a little higher than that other one on 40. 19 and 40, oh, these are really close together. And then 34 and 58, so 34 and 58 would be like right here. All right, so we want to know, is there a variable association? Is it positive, negative, or none? All right, so our associations, we're kind of looking at a line. If we're looking at the slope of the line, so if we drew a line kind of through these points, is it a positive slope, negative slope, or is it nothing? And this I would say is positive. As x got bigger, so did y. Y increased. Is it a linear association? Well, I would say yes, because they're fairly close to this line right here. They're not exactly on the line, but they're not really far off. It might help to actually have more data. If we had more data, we might see a line there, or we might see not a line there, and then we could say it's not linear. But based on what we have, I would say it's linear. Do you see any clusters? Well, you have groups of points that are kind of close together. These are really close together, but there's only 2 of them. So because there's like 2 here and 2 here and 2 here and 2 here, I would not really, since nothing really stands out to me as a cluster, I'm going to say none. You can make a case for these 2 since they're pretty close, but again, there's just 2 of them. Do you see any outliers? I mean, they're all fairly close. I would say no. And then the conjecture is about the number of units produced in 50 hours. All right. So if I take my graph, so here's 50, and I extend my line to 50, then it's going to be about what? It's kind of falling between 70 and 80. So I could guess that this would be about 75 units that would be produced after 50 hours. Okay, so scatter plots, it's kind of like using a coordinate plane. Now we're just using it with data. And then finding some associations that we can use to sort of predict what's going to happen with the information we're given. All right, I will see you soon.